Okay, hello everyone. Today I'd like to present to you the proof of concept application that I've been working on, which is Engenuity, the knowledge assistant. And ultimately the purpose behind this application is to empower engineering teams with knowledge at every step. So I work as a structural analyst at an automotive company, and I've experienced firsthand the critical gaps in the way knowledge is managed and shared. And so one of the biggest challenges that we face in our organization is knowledge retention. So as engineers transition between projects, valuable insights, design decisions, if these are not properly captured, they are often lost in the shuffle. So this lack of continuity leads to inefficiencies and sometimes even duplicated efforts. Another significant issue is data overload. So this is the case when knowledge is captured appropriately in structured documents. They can still get lost because there is a constant influx of documents, notes, design iterations, and project updates. And it's easy to become overwhelmed by the sheer volume of information. So typically engineers and designers, they can struggle to find relevant details quickly when you have the sea of information. And that really hinders that decision-making process and slows down project timelines. Actually a specific example of this that I can attest to involves setting up a simulation model to evaluate deformation behavior of a structural component. So in my case, this project, this model was new to me, so it took me several days, in fact, to really tune the model parameters, the finite element model parameters, that would eventually get it to run and converge to a solution. So this was that light bulb moment, which led me to ask the question, can we build a system that leverages our existing structured documents, the way we store information, and then can we push that all into a central database, which can then be leveraged by other team members in our group to ask questions about new projects that they might be dealing with specifically. So now going back to those parameters, for my model, if I had this system, I could inject that information into that database so that at some later point, someone else can, instead of wasting days trying to figure out those parameters, they can tap into that resource and get those parameters very quickly. So this is where the knowledge assistant comes in. The main feature is, of course, document upload. So you would upload your structured documents, and then, as I said, you can then retrieve those documents. The system can retrieve those documents when you ask the system questions pertaining to your problem. And now we can take a look at how it works. So under the hood of this application, I'm running a modified version of a deep research reasoning design pattern. So at a high level, once documents are uploaded to the database, a user can go use the application, they can ask a question, which then steps to this generate query step. Here, the language model reformulates that query so that it retrieves the most relevant information for you. And that's actually performing the document search step. Documents are retrieved, and then there is a grading aspect to that step, that node, where that entire list of documents that were retrieved are inspected to evaluate which of those documents are the most relevant. These are then passed to the summarize sources step. And here, this is where everything happens in terms of the content creation, the writing. And then once that step is done, we move on to a step where we reflect on the summary, or the language model reflects on the summary so that it can formulate more queries to do the document search and then summarize sources and go in this loop until we get the final summary. So now I will quickly jump to the demo here. So because I'm not the best typer, I have a question typed up here. I'll just copy and paste it. Here I am asking a question about a particular type of structural metal. And this is a magnesium alloys. This is a magnesium alloy metal. It's a very new type of metal that people are starting to use for structural applications for its mechanical properties. Anyway, let's run the demo, and we can see when I ask this question, the assistant is stepping through. Of course, this is a POC, so we still have these artifacts that appear. But ultimately, in a clean, polished version, you would end up with this content here, which is really giving you an explanation to the question that you asked. And we can ask a follow-up question, and you will get a response that is satisfactory. I have actually gone through this response, and these are, in fact, accurate. But of course, this is something that needs to be explicitly outlined to the user. And this brings me to the future work for this project. And here, as part of future work, because this is intended to be used in a group environment with multiple users, I'd like to add in user authentication. Of course, deploy this locally because we are dealing with proprietary information. So we'll be leveraging VLLM and Olama to run our language models, or to use the language models. And then another feature that I want to have here is a call out for reasoning steps, and to have an instruction input field so that we can refine or guide the agent towards the type of answers that we want to receive. Of course, tables and images are very important when we're specific, especially when we're dealing with metals, for example, and we really want to get microstructure images. We want to be able to visualize that, of course, along with tables that call out the material properties and the material strength and all that stuff. And then, of course, the reference list, which I mentioned before, this is absolutely critical. We need to have this. And of course, we need to have in-text citations to further justify the veracity of what is being printed out onto screen. And then another thing which would be really useful, especially when you're working on projects that span several months with multiple engineers, is the ability to persist long-term memory. Because in doing so, in capturing that conversational interaction with this language model amongst many users, over time, you can really collect question and answer pairs and essentially carve out a space of question and answers relating to a particular project, which is really relevant to that project. And that way, in a future scenario, when you take on a similar project, you can really tap into that stored conversational history context to get really fine-grained answers to your questions. And yes, this is, oh, sorry, the last thing is feedback, of course, because you do want to continuously improve the back end, the front end, everything. So continuous feedback is also something that needs to be integrated into this application. And that is it. This is Knowledge Assistant, and it is empowering engineering teams with knowledge at every step. Thank you for your time. I'll be happy to take any questions right now.